Yes, doctor, it's clear, visible.
Okay, nice. So now I make it a full screen. So I think you can see it as a full screen. Okay. So if you remember, last week we have learned about forward kinematics. So one of the way we are trying to use for the forward kinematics is Denavit Hartenberg. Oh, sorry. We have another member. Okay, Salah, welcome. Assalamualaikum. Okay, so last week we have learned about forward kinematics, and our focus is an industrial standard using Denavit Hartenberg. So Denavit Hartenberg is what do you call it? It's not mathematically easy to understand, but it is really easy to use this formula. And using this formula, we can compute our robot much more faster. And therefore, this is the current industrial standard. They use Denavit Hartenberg. Okay, for the last week, we have learned how to assign the frame for our robot. So we have learned several rules how to assign X, Y, and Z. Now, the second part, we want to fill out a DH, which is Denavit-Hartenberg parameter table. So based on this table, we can get the forward kinematics. Okay. So this part is a little bit tricky. So I would like to have a discussion, or if you want to have any question, you can just directly ask me during our class. Okay. Okay. So basically, there are only four uh, parameters that we need to find for each assigned frame. Okay. So these are the four parameters. Let's go for the first one. So today we will learn only how to find these four parameters. Okay, the first parameter is theta. Let's say this is your robot frame, and maybe this is your robot like this. And the robot have two joints. Okay, one is on this part here, another one is here. So these two are the two joints. Okay, sorry, there is another one more members want to join. Okay, so today we will learn how to find these four parameters to get the forward kinematics. Okay, so as I said before, we have these two motors. Okay, and then we want to define the parameter theta 1. To define this parameter, we need to rotate the frame of Zn axis, Zn minus 1 axis, so that the axis Xn minus 1 is the same with Xn axis. Okay, so the tricky part is the Xn, the n minus 1 n minus 1. This is n. Okay. Let's say your n is 1. So your z will be zn minus 1 will be 0. Your xn minus 1 will be 0. And your xn exists here should be 1. Okay. So let's see how should we do this. Okay. To get your first parameter for your frame n1, which is theta, you need to rotate the zn minus 1, which is this one here. You rotate using this way. Make sure that your xn minus 1 is the same with xn. Okay, that's all. However, there is additional rules. If your join x at the xn minus 1 or zn minus 1 here, if this join here is active joints where you move this joint by using a motor. So if that is the case, okay, yes. If that is the case, you just need to put this value as theta, which means you can turn this joint here using any value theta. Okay. So I will show you an example. This is your zn minus 1, yn minus 1, xn minus 1. So this is your robot like this here. So then you have another joint here. Okay. So this is zn, yn, and xn. So if I want, if I rotate zn here, so that zn minus 1 here, so that the xn, this one, is the same, xn minus 1 is the same with xn. What is the value for the theta? Okay.
Yeah.
So to do that, your first step is to move this joint here, move to the joint of Zn frame, like that. Next, you need to rotate using the Zn minus 1 so that the Xn minus 1 is the same with the Xn here. So basically, we rotate about 90 degrees. Therefore, your theta will become 90 degrees. Okay, because we rotate it like that. So it is from here. So basically, this is coming out from the screen. So this is about 90 degrees. So you rotate this one to overlap xn. So this is xn minus 1 before. We move it to overlap xn, and the rotation is 90 degrees. So you should put your theta here as 90 degrees. However, there are extra rules. If this joint is an active joint, so you just put it as a theta, as a variable. Okay.
Okay.
Okay. By doing that, you can have the first parameter for the Denavit Hartenberg. Okay. Do you have any question on this part?
Yes, I do have one question.
Okay.
Yes. So you said there is an extra rule when if this joint is an active joint, meaning that it's moved with an actuator motor. Okay.
Yeah.
So that means the case that we put the values the join will be rigid, it's not moving, or what? Like if the arm was attached to a surface or something which is not moving, or
Yeah, if the arm is not moving, it's rigid. So you need to put the theta value as a degree, like 90 degree or 8, depends on your rotation. So how many degrees? So you need to put that value because it is rigid. However, if that joint is a moving joint, you just need to put it as a theta. Okay, did I answer your question?
yes, you do.
Okay.
Thank you.
Okay, it's good. So any more other question? So maybe it is simple.
Mm.
Okay, let's move to the next one. So we have finished our first parameter. It's easy, right? So let's move to the second parameter, which is D. Okay, the same. Let's say we have your robot joint, one here. Another one is at this point here. Okay. So this is Zn minus 1, which is, this is the frame for n minus 1. This is frame for n. It's just the same thing. I just want to say it. So to get D, D is the distance between this point here, middle of here, to this point here, in terms of movement on the Zn minus 1 axis. So you move this point here until it is the same with this point here by going through the Zn minus 1 axis. So this is the example. So you just move this one going up here, and that movement of distance, it is the D. Okay. So you
Okay.
just need to remember that you need to move on the Zn minus 1 axis. It's almost the same with the previous one for theta. So this is the previous one for theta. Okay, for theta you need to rotate the Zn minus 1 axis. Okay, for D, you need to move along the Zn minus 1 axis.
Okay.
So okay, easy. So these two, you just need to move or rotate along Zn minus 1. So you move the Zn minus 1, and that movement of distance is D. Okay,
Okay.
so this value should be Dn. Okay,
All right.
okay, so we finish for the second parameters. Do you have any question on this parameter?
I guess no.
Okay, good. So I think currently everything is good.
Alhamdulillah.
Alhamdulillah, right? Okay, the another two parameter is a bit different. We will move along or rotate along xn. So previously is Zn minus 1. Here is Zn minus 1. Here is xn. So the difference is Zn minus 1. This is just xn. Which means this part we will move along the xn axis. So the xn is this one. Let's say our n is equal to 1. So the this one will be x1. This one will become xn minus 1, which is x0. Okay, can you see it? Okay. So now we need to move along the xn axis between this point here to this point here. So because the xn is going this direction, so it will become like this. So you get the distance between this point here to this point here. So that is the value for an. So just put that as an. So the only tricky part that you need to move is the xn axis. Okay. So the final part, so we have moved along the xn axis. For the final part, which is the alpha, which is we just need to rotate. We just need to rotate the xn axis so that the zn minus 1 is the same with zn. So this is a bit tricky, which means you need to rotate this axis here. So this one should rotate like this. You rotate until the zn minus 1 is the same with zn. Okay, so
Okay.
to do that, you bring this frame here, frame n minus 1 to this frame here, like this. Then you rotate it using a right hand rule. Okay, you just rotate this one so that the zn minus 1 is the same with zn. So this one, the rotation should be 180 degrees. So the value should be 180 degrees. Okay.
Okay.
Doctor, the one that we are rotating is the blue one or the red one?
The blue one, the red one, but we will rotate along the x and axis. So if the x is here, so you will rotate this one like this until this one is the same with this one. So we will
Okay, so we are rotating the
yeah.
so we are rotating the previous frame until it matches the current frame,
Yeah.
the end.
Yeah.
Okay.
Okay. So that's all for the DH parameter rules. Okay.
Okay.
Okay. Finish. So let's see one example. So as usual, we will try to do an example for Stanford robot from Stanford University. Okay, so this is your robot. We can represent it like this. So there are a rotation like this, rotation here, and there is a linear movement like that. So we can represent the robot on the right with the figure on the left.
Okay.
And this is your figure. Okay, it looks bad, but
Okay.
I think it's still understandable.
Yes, just plenty of information.
Okay, so let's go. Let's try to fill in the DH parameter for this robot.
Okay.
So you want to fill in this table here. Okay, so if you remember, this one is rotation on the zn minus 1 and move along zn. This two is move along xn and rotation on the xn minus 1 axis. Okay, let's see. So we start with n is equals to 1. So if n is equal to 1, the zn value will become,
Okay.
if n is equal to 1, so the zn minus 1, n minus 1
Zero.
becomes 0, yes. And the xn will become
1.
1. So the x1 and z0. So here is the frame for 0. here is the frame for
1.
1. Okay, so this is your n currently, and this is your n minus 1. So now you need to for theta, you need to rotate at the z0 frame, because n minus 1 is z0. So you need to rotate for the z0 frame. You need to rotate until the x0 is the same with x1. In this case, it is the same, right?
Yeah.
You don't
Yes.
need to rotate the x. And in addition, this joint here is an active
Moving.
joint.
Yeah,
Yeah,
active join.
which means this value of theta
Theta,
will become
So,
a
theta 1.
variable.
Yeah, a variable. Yeah, that's true. Okay, now we have filled in the first theta. Next is d. Okay, so
Okay.
for d, you need to move along the z0 axis, moving this direction, so that the frame, this frame here, which is frame 0, will become the same as the frame 1. So you just move along the z0 axis, so that this point here is the same with this point up here. So if you move this direction, you can see it is the same as A1.
A1.
yeah.
Okay, can you see it? Okay.
Yes.
Now we have finished on this part. Okay, now we will go on this part here, which is move along and rotation on the x1 axis. Okay, so now we will look at this axis here. So for AN, we move along the xn axis, which is x1. So we move so that these 2 point, which is this point here, is the same or parallel with this point here. So currently these 2 points are at the same. We don't
Yes.
need any movement. Uh, we don't need any movement on the axis of x1. So the value of A is 0.
0.
Okay. So finally, we need to rotate on the x1 axis. We need to rotate it so that the z0 is the same with z1. So we bring this frame, the 0 frame, up to the frame on top. Okay, we bring it here.
Right. Okay.
So this is XO. This is
Y1.
YO. This
Y1.
is ZO. So we need to rotate this direction here so that the Z0 is the same with Z1. So we need to rotate about 90
90
degrees,
degrees.
right? So this answer should be 90 degrees. Okay.
Okay.
Okay, do you have any question on this part?
Nope.
Okay. No? Okay. Okay, let's continue to the last frame, which is frame 2. So the n is equals to 2. So here, the zm minus 1, 2 minus 1, which is
1.
z1, and xn, n is equal to 2, so it will become x2. So let's see, for theta. Theta, we need to rotate z1, right? We need to do the rotation of z1 so that the axis of x1
X1.
is the same with x2. Okay, because this robot have a active joint, which is theta 2 here, So the value of theta is easy. You just put it as theta 2.
Theta. Okay.
Yeah. So the value of theta is also important. This is theta 1. This is theta 2. Okay. Now we need to move along the Z1 axis. So where is the Z1 axis? Yeah, I will use another color. Okay, this is the Z1 axis. So you will move along the Z1 axis so that this point here is parallel with this point here. If you look here, both of the point are the are parallel, so you don't need any movement, right?
Yes.
So the value of D is 0.
0.
So you don't need to move this point here in this direction so that it become parallel. So these two are already parallel. So you don't need any movement. Okay. So we have finished on the left part here. So let's go to the right part here, which is AN and alpha n, which is A2 and alpha 2. So our X is X2. So the first one, we need to move along X2. So this is our X2. So we want to move along so that this point here is the same with this point here. This point here is the same with this point here. So we want to move the point for joint 1 along axis X2. So we are moving this point here along the X2. So we move this point. So the value of this parameter is
A2.
yeah. Okay. It's A2. Okay. Okay. So for the final one, we just need to find the alpha. Okay. So for this one, the alpha should become
0.
okay, 0 because this is we need to rotate on X2. So what we do, we bring this frame here to this frame here. So this one is Y1. This is X1 and this is Z1 because Z1 and Z2 is already overlapping, so the value is 0. Okay, Alhamdulillah, we have finished the DH parameter for our Stanford robot. So let's go for the second example. Before that, after you already get all the value for the parameter, next, you need to fill in this parameter into the DH matrix. Yeah. So if you have 2n, so you have uh, two matrices. If you have 6, you have 6 matrices. Okay. So, but in today's class, we will not go through this part first. Okay. We will look into another example, SCARA robot. So let's try to make this class a little bit interactive. So if possible, I would like to give each part to a different person. Is it okay?
Okay.
Okay. This one is for Abdullah. This one for Salahuddin. Salah. Correct.
Yes, correct.
This one is for Nurul Hidayah. And finally is for Mr. Raid.
Yep, Rad.
Rad.
Yes, RAAD.
Okay, Mr. Rad. So the final one is for Mr. Rad. Oh, sorry. And final, this one should be for so Dunia. Sorry if I mispronounce your name. It's a bit different with my country. Dunia. Okay. So just okay. This one is for Dunia. Okay. So maybe I give you 5 minutes. Is it okay? Can you try to find the answer for each of this part here? And if
Okay.
you have any question, you can ask me. Right now, it's okay.
Okay, I'll now get my portion. Joshua.
Oh, Joshua, sorry.
Yes, okay.
So this one for Joshua.
Okay,
I'm spelling your name right? Am I?
that's it, that's it.
Yes.
Yeah, alhamdulillah. Sorry.
Okay. For frame. Yeah, I think the first one is easy. I mean, my part.
Okay. The first one is
It's always theta as a variable. Since the moving, it's an active join, isn't it?
yeah, because this one is a active rotation joint, so it is theta. You're correct. But some doesn't have a rotation, active rotation. So you need to look either this is a active joint or not.
Okay. So that's
In
theta
my,
one.
in my part, I think it's equal 0, isn't it?
Yours is which one?
This one, alpha n.
Alpha n, which is alpha 1. Okay. So yours, okay, let's see. So this is Z0 and Z1. Yeah, it's correct. Should be 0.
For me, it's A1.
A1, okay. Oh, for the D1, the value is A1. Yeah, it's correct. Okay, how about Hidayah?
I think is A2.
Okay, so okay, so let's try to do it. Well, okay, for the first one is A1. Okay, so A1 we need to move along Z0 axis. So this one, the movement from this point here to this point on the Z0 axis. So we move like this until this point here, which is A1. So the D1 is A1. It's totally correct. Then we go to the AN. AN is the movement along X1 axis. Right. This one will be Xn. The n is 1, so X is X1. So we move along this axis here from here to here. which means we just move this point here until we arrive at this point here, and that distance is A2. Totally correct, Hidayah. Finally, we need to rotate at the x1 axis. At the same time, we need to bring this one to here. So we have this one. So this one is z0. This one is x0 and y0. Because both of z1 and z0 is at the same place. So this one alpha, there is no rotation on the x1 axis, so it is 0. So everyone is correct. So finally, we arrive to the second and
Mine is A3.
I think for me it's theta 2.
yeah, okay. Because this is an active joint here, so the value is theta 2. Totally correct.
This one A3.
Yes.
A3.
Okay. So yours is A3. Okay. So Joshua, right? So
Yes,
Joshua,
doctor.
let's see. So for Joshua, we need to move along x n, which is n is 2. So it is x2. So we move along this point here, x2, so that this point
That's
here is parallel with this point here in this term. So you should move like this until this point here, and that distance is A3. So it is totally correct. I think it's easy, right?
That's
Okay.
nice.
Okay, now how about the alpha 2? What do you think the value for alpha 2?
Alpha 2 is supposed to move in x2 until the z, rotating until the z1 and z2 match, right? So it should be 90 degrees.
I think it should be a little bit more than 90 degrees.
No.
Okay, 1 second. It is, the movement should be clockwise, right?
Doctor
Uh,
is the same 0.
so the movement is
Sorry,
like this.
180. Correct,
Yes,
180.
correct.
No movement.
So you use your hand here. So this is your hand. So this is
Okay.
your
Z.
axis of rotation like that. So, and this is your palm. So if it is moving like this is positive. So you use your right hand. Oh, sorry. We have another person.
It's 180, I think.
Yes, that's true. So it's just maybe Abdullah, you confused that this one is 90 degrees, but actually it is 180 degrees.
Yes,
So
it's 180 degrees.
yeah,
Totally the opposite direction.
yeah, that's totally. But yeah,
Thank you.
so you just bring your axis one here, and you overlap everything. So this is your zn, yn, and this is your x1, y1, and z1. I just bring everything from here to here, and then you can see the rotation here, rotation this way. So using the right hand rule, you rotate the x2 axis and so that the z1 axis you rotate until it is the same with
180.
z2. which is 180 degrees. So maybe you have a question. Can you put negative 180 degrees? How about you do it, you turn it around another way around here. So it will become negative 180 degrees. Is it okay? Actually, it's okay because
It
we
will
are
be
using,
in
yeah.
counterclockwise direction.
Yeah, I mean, if for positive 180 degrees, we can use negative 180 degrees. You will get the same value if you put it in your sine cos
Okay.
theta. Okay? So this one is okay. Okay.
Okay.
But for 90 degrees, you cannot do it like that. Like 90 degrees, it's not the same with negative 90 degrees. 90 degrees is the same with negative 270.
270.
Yeah.
270.
So it's just for 180 degrees, you can put it positive or negative. Okay. So for the third one, what is the value for theta? Yeah. This is a bit confusing.
Is it this considered as an active frame as well?
Because this one doesn't have any rotation. So I will try to clear our screen first. There are too many things.
Okay.
Okay. Okay. Let's do it again. Okay. So there is no active rotation here. This is a prismatic movement, right?
Okay.
There is no rotation.
So no theta at all.
So the theta,
Zero.
okay. You need to rotate the Zn minus 1. So your n is 3. So you need to rotate Z2. You need to rotate so that the x2 will be the same with x3. In this case, these two are the same. So the value will become
Zero.
0. Yeah. So this special case, so it is 0. Okay. Then next is your D. So you need to move along the Z2 axis so that this point here is the same with this point here by moving along the Z2 axis. So
That's
this
D3.
distance is, what is this value for this distance?
A4.
A4.
A4, yes, correct. But we have a little bit additional because of the drawing is a bit bad. Actually, it is like this. You have A4. So this is like your beam on your robot. And you have a D3 on this part here. D3 is the movement of your beam. So you can extend this point here. So, how do I make it? So this is your robot. It is holding a beam here. So this one can move. This movement is D3. Okay. So sekarang
Oh,
robot
okay, okay.
that movement up and down, up and down.
Okay,
That
so
yeah.
so the total, this is the A4 plus D3. This is the total length of the thing, entire thing.
Yeah. Okay. Can you see it? Okay. So you just plus these two from here to here. So the A4 value, it is rigid. 4 meter maybe doesn't change, but the D3, it is a moving joint. It's always change. So D3 is actually a variable. Okay. Okay.
Okay.
Okay. Now we go to the final part, which is Zn. Sorry, Xn here.
Xn.
Xn is equal to X3. So I want to change my color here. So here, so the first one, we want to move along the joint X3. Because these 2 points are parallel, you don't need to do any movement to make it the same. So this value will become 0. Okay, because you don't need to move along this joint along axis X3, so that this 2 point is the same. It's already the same, right? Okay. And finally, you need to rotate the X3 axis so that the Z2 and Z3 is the same. So if I draw Z2 axis here, Z2 and X2 and Y2, everything is at the same axis. Z2 and Z3 is on the same axis, so the value is
0 also.
okay. Finish. So finally, you have this metric here. Now what you need to do, you need to fill in all the value. So I will give you an example. For T, n is equal to 1. Okay, here 1. So this is 1. This is n minus 1. So this is 0. Then we have our big metric here. So first one, C theta. So it will become C theta 1, which is cos. Sorry. This is cos theta 1. Then minus sine theta 1. And the alpha is 0. Right. Alpha.
Yes.
So if alpha is 0, cos 0 will become
Cos 0 is 1, I think.
1.
0, 1. Okay.
Yeah, okay. So it's simple, that one. And then we just fill in the next one, which is here. Theta,
0,
the 1. Sine 0 is
0.
0.
0. So this one will become
0.
0. And an is 2. So a2 cos theta. Cos theta 1. Okay. So finish the first one. Next one is sine theta 1. Okay, this one here. And then we have cos theta 1. Cos alpha. Alpha is 0, so it is 1. This one is negative cos theta 1. And sine alpha, sine 0, which is 0.
Entire parameter is 0.
Yeah, so this will become 0. And this one is a2 s theta 1. Continue this one. This one is 0. So this one here. And the s
0 also.
alpha, so 0, because sine 0 is 0. And this is cos 0, which is 1.
1.
And b1 is a1.
A1.
Oh, sorry, a1. And the last one is 0, 0, 0, 1.
1.
So you need to fill in all of this one. Okay. Then you will have a 3 matrix. So it will become P01. Then you have P
1, 2.
1, 2, and T 2, 3. So if you want to get your forward kinematics, what you need to do as before, you just need to multiply everything. So first you multiply 302 by multiplying T01 multiplied with 1, 2. You get T02. Then you need to multiply again 303, T03. So you need to multiply T02 with T23. Then you have your forward kinematics. Your final matrix will become something like this. It's the same, 4 by 4. But you need to multiply all of these matrices here. Here, this one, and this one. Okay. So by doing that, you can have your forward kinematics for your robot. Please bear in mind that DH, which is Denavit Hartenberg, for kinematics, you just need to do only once in a lifetime. If you build your own robot arm, you just need to do your forward kinematics only once. Then you can already use this formula, which is T03, to move your robot arm. Okay, so this is example for Puma robot.
Wow, that's an advanced one. Okay.
Yeah, it's advanced, but let's do this on our next week class. Okay.
Thank you, Doctor.
Okay. So that's all for this week. Okay. And I think all of you did get a correct answer. So I am happy.
Alhamdulillah.
Alhamdulillah. So currently I'm open to any question if you have. Okay. Or some we have some chat here. Let's read. Okay. If you don't have any questions, so I think we can finish our class from here. I will upload this class recording in YouTube. Okay, so you can watch it if you want to. But I think nobody watched.
That's somehow embarrassing.
Maybe near when we have a test, you need to maybe you want to watch some part of this video, so you can do it. Okay, so okay, alhamdulillah. So next week we will have another class, and then the week after that we will have a holiday for Eid Fitri, right?
Yes.
So hopefully you have a good Ramadan. I think this is the final 10 days. So let's give more time for prayers, inshallah.
Inshallah.
Okay, so that's all. If you have any question, you can continue in WhatsApp if you have any. So thank you very much for joining class for today. Assalamualaikum warahmatullahi wabarakatuh.
وعليكم السلام ورحمة الله وبركاته.
Okay.